All right, so yesterday we learned how to determine theoretical yield. Today I'm going to teach you how to determine percent yield. Okay, percent yield. What does that mean? You're about to find out. Really, all we're going to do is add one itsy bitsy little step to what we did yesterday. All right? We just figured out how to determine theoretically on paper how much product should be formed. Will that much product be formed? No. I mean, the fact is that on Thursday we're going to do a lab and we're going to try our best to make sure that all the copper that we make, we collect. Invariably, some of it will be lost. So I'm going to ask you to find the percent yield. How much did you actually collect of what you should have collected? That's what this is all about. Why is it impossible? Because when you're scraping, when you're scooping, in the case of factories, when you send a bulldozer in and start picking stuff up and dumping it into a container, you know you're going to lose some stuff. The factory takes that into account. The factory will actually tell the engineer, we want 90% yield. And what that means to the engineer is, I need to design it in such a way that only 10% of the product is lost. So, percent yield is quite simply what you actually recovered divided by what you should have recovered. The actual divided by the theory. The theory is what you get on paper. The actual is what you get. I will always give you the actual yield. You have to determine the theoretical yield and then the percent yield. Okay? That sounds really tricky. It's not. Let's do this question. Calculate the theoretical yield. In other words, do what you did last night. Let me give you the balanced equation. All right. I'll do it quietly up here. You do it. All right, so I have 69.5 grams of carbon monoxide. That's how much money I have in carbon monoxide land. So I go to the bank and I say, hey, I want to convert it all over to moles. So a bank will always tell me, we'll give you 1 mole for the formula mass. 12 plus 16 is 28. Then I have to go to the Chamber of Commerce because I want to see how much it's going to cost to live in my new country. And my new country is methanol. Okay, so moles of CH3OH. And I'm going from CO land. And that is 1, 2, 1. And then after I travel to CH3OH land, I find out that people there use grams exclusively, and they make fun of the people that use the mole. So I decide to give in to peer pressure and go to the bank and say, hey, can I exchange all my moles for grams of this country? And they'll say, sure. For every one of your moles, we will give you formula mass, which I think is 32. All right, do the same thing for hydrogen. Esther, you got the first one? I need the second one as soon as somebody has it. All right, I'll stop right there and let you confirm that. All right, so we have two answers. Only one of those can be the right answer. Which one is the right answer? The smaller one. So the smaller one is the right answer, which makes this guy your limiting reactant, and the one that gives you the greater answer is in excess. All right, how do we find percent yield? Well, what we do is we say, okay, how much should we have gotten if everything was perfect? 68.8. According to the question, how much did we get? 35.7 grams times 100. That's it, folks. The question itself will always give you how much was recovered. You divide that by how much you should have gotten, which is your theoretical yield. The answer is 51.9%. That's that little step that I told you we had to add. That's it.